The solar system appears at first glance to be a quiet and orderly neighborhood in the vast chaos of the universe. 8 planets orbit a stable star, following predictable paths, accompanied by moons, asteroids, and comets that seem to obey a well-understood set of gravitational rules. But beneath this apparent simplicity lies a deeper mystery, one that stretches back billions of years and continues to evolve even now. The true story of the solar system is not one of calm permanence, but of violent beginnings, hidden structures, and unresolved questions that challenge our understanding of how cosmic systems are formed and sustained. Roughly 4.6 billion years ago, the solar system began as a vast cloud of gas and dust, known as a molecular cloud. Something disturbed this cloud, perhaps the shockwave of a nearby supernova, and caused it to collapse under its own gravity. As it collapsed, it began to spin faster, flattening into a rotating disk. At the center, pressure and temperature increased until nuclear fusion ignited, giving birth to the Sun. Round it, particles began to collide, stick together, and grow. Over millions of years, these small grains became rocks. Rocks became planetesimals, and planetesimals merged into protoplanets. This process, known as accretion, sounds straightforward, but it hides a violent truth. Early planet formation was chaotic. Objects frequently collided at tremendous speeds, sometimes merging, sometimes shattering into debris. One of the most dramatic examples of this violence is believed to have formed Earth's moon. A Mars-sized body, often called Theia, may have collided with the early Earth, ejecting material into orbit that eventually coalesced into the moon. This theory explains many of the moon's characteristics, but it also raises questions. Why was such a collision possible? And how many similar events shaped the other planets? The arrangement of the planets themselves presents another puzzle. The inner planets, Mercury, Venus, Earth, and Mars, are small and rocky. Beyond them lie the gas giants, Jupiter and Saturn, and then the ice giants, Uranus and Neptune. This structure seems logical, with lighter gases dominating the colder outer regions. This migration would have scattered smaller bodies throughout the solar system, possibly triggering a period known as the Late Heavy Bombardment, when countless asteroids and comets bombarded the inner planets. Craters on the Moon and Mercury still bear witness to this era of destruction. But the timing and intensity of this bombardment remain uncertain, leaving scientists to debate how stable or unstable the early solar system truly was. Jupiter itself plays a central role in many of the solar system's secrets. As the largest planet, its gravity dominates the region. It acts as both a protector and a threat. On one hand, Jupiter's immense gravitational pull can deflect comets and asteroids that might otherwise strike Earth. On the other hand, it can also redirect objects inward, increasing the likelihood of impacts. Its influence extends far beyond its orbit, shaping the asteroid belt and even affecting the stability of other planets over long timescales. The asteroid belt, located between Mars and Jupiter, is another enigmatic feature. Once thought to be the remnants of a destroyed planet, it is now understood as material that never formed into a planet, largely due to Jupiter's gravitational interference. Yet within this belt, there is surprising diversity. Some asteroids are metallic, others rocky, and some contain water-rich minerals. This diversity hints at a complex history of mixing and migration, suggesting that materials from different regions of the early solar system were scattered and redistributed. Even farther out lies the Kuiper Belt, a vast region of icy bodies beyond Neptune. This region is home to dwarf planets like Pluto and Eris, as well as countless smaller objects. Beyond it still is the Oort cloud, a hypothetical spherical shell of icy bodies that may extend halfway to the nearest stars. These distant regions are thought to be the source of long-period comets, but they are so far away that direct observation is nearly impossible. Their existence is inferred from the behavior of comets, leaving room for uncertainty and speculation. One of the most intriguing mysteries of the outer solar system is the possibility of an undiscovered planet, often referred to as Planet 9. Observations of distant objects in the Kuiper belt show unusual clustering in their orbits, suggesting the gravitational influence of a large, unseen body. If it exists, Planet 9 could be several times the mass of Earth and orbit the Sun at an enormous distance. Yet, despite extensive searches, it has not been directly observed. Its existence remains one of the most compelling unsolved questions in planetary science. Closer to the Sun, mysteries persist as well. Venus, often called Earth's twin due to its similar size and composition, has evolved into a hellish world with surface temperatures hot enough to melt lead. Its thick atmosphere traps heat in a runaway greenhouse effect. Why Venus and Earth followed such drastically different evolutionary paths is still not fully understood. Mars, on the other hand, shows evidence of ancient rivers and lakes, suggesting it once had a much warmer and wetter climate. What caused Mars to lose its atmosphere and become the cold desert we see today is another ongoing question. Even Earth, the most familiar planet, holds secrets tied to the broader solar system. The origin of water on Earth, for instance, is still debated. Some scientists believe it was delivered by comets or water-rich asteroids, while others argue it was present from the beginning. The answer has implications for the likelihood of life elsewhere, as water is a key ingredient for life as we know it. The Sun itself is not as constant as it appears. It undergoes cycles of activity, including solar flares and coronal mass ejections that can affect the entire solar system. Over longer timescales, its brightness has increased since its formation and will continue to do so. In billions of years, the Sun will expand into a red giant, potentially engulfing the inner planets. This future transformation reminds us that the solar system is not a static structure, but a dynamic and evolving system. Another layer of mystery lies in the distribution of angular momentum. The Sun contains more than 99% of the solar system's mass, yet most of the angular momentum is held by the planets, especially Jupiter. This imbalance is not fully explained and suggests that processes during the early formation of the solar system redistributed momentum in ways that are not yet completely understood. Magnetic fields also play a role in shaping planetary environments. Earth's magnetic field protects it from solar radiation, making life possible. Mars once had a magnetic field, but it disappeared, leaving the planet exposed to the solar wind, which stripped away much of its atmosphere. The mechanisms behind the generation and loss of planetary magnetic fields are still being studied, adding another piece to the puzzle. In recent decades, the discovery of exoplanets, planets orbiting other stars, has added new context to the mysteries of our own solar system. Many exoplanetary systems look very different, with giant planets orbiting extremely close to their stars or highly eccentric orbits that would be unstable in our system. This raises the question, is our solar system typical, or is it an unusual case? The answer could reshape our understanding of planet formation and the potential for life elsewhere in the universe. Ultimately, the solar system is not just a collection of celestial objects, but a complex, interconnected system shaped by gravity, time, and chance. Its current structure is the result of countless interactions, collisions, and migrations over billions of years. Yet, despite all we have learned, many questions remain unanswered. Hidden planets, unexplained orbital patterns, and the origins of key features continue to challenge scientists. The deeper we look, the more the solar system reveals itself not as a solved puzzle, but as an evolving mystery. Each discovery leads to new questions, and each answer uncovers layers of complexity that were previously unseen. In this sense, the greatest secret of the solar system may be that it is not fully knowable, not yet, and perhaps not ever. It is a story still being written, a dynamic system that continues to surprise us, reminding us that even in our own cosmic backyard there is still much to explore.